angiotensin mechanism. How the renin-angiotensin mechanism controls the blood under pressure. The renin-angiotensin mechanism, this is a group of related hormones that act together to regulate the blood pressure and control the inflammation. It is called the system because each part influences the other part and all are necessary for the whole to function correctly. The renin-angiotensin mechanism work together with the kidneys. It is a vitally important part of the body's blood pressure regulation system. More specifically, this is done through the classical renin-angiotensin. Inappropriate activation of the classical pathway can also lead to some harmful effects such as the hypertension, which is sustained the high blood pressure and the development of the vascular disease. However, the renin-angiotensin system also promotes a protective anti-inflammatory response through its alternative renin-angiotensin pathway. Together, the classical and the alternative renin-angiotensin system pathway create the responses that oppose one another but balance on the effects. How classical RAS pathway works. The important members of the classical RAS pathway are renin, angiotensin 1, angiotensin 2, angiotensin converting enzyme and the aldosterone. Renin. When the blood pressure drops for any reason, special cells in the kidney detect the change and they release renin into the bloodstream. Renin by itself does not really affect the blood pressure. Instead, it floats around and converts the angiotensinogen into angiotensin 1. Angiotensinogen, this is a molecule that is primarily produced by the liver and circulates throughout the bloodstream. It is not able to alter the blood pressure as a precursor molecule. It must be transformed into the active form of angiotensin. Here you can look for the angiotensin 1. Angiotensin 1, this is also does not affect the blood pressure much itself. Instead, most angiotensin 1 is converted to angiotensin 2 as much more powerful hormone that does cause the large changes in the blood pressure. Angiotensin converting enzyme 1. This second conversion, which produces angiotensin 2, happens mainly in the lungs via the action of a molecule called the angiotensin converting enzyme. More specifically, it is called the angiotensin converting enzyme 1. This conversion can be blocked by the drugs called the ACE inhibitors, an important type of high blood pressure medication. Angiotensin 2. This is a very powerful hormone that can act directly on the blood vessel, causing them to become narrow or constrict to increase the blood pressure. It has another important function as well, stimulating the release of aldosterone. Aldosterone is an hormone that increases the blood pressure by causing the kidney to retain both salt and the water, which over time increases the amount of fluid in the body. This increases in turn raises the blood pressure. The effects of the renin-angiotensin pathway, neural and the renal. Aside from the blood vessel, angiotensin 2 can also bind to the receptors located in the different areas of the body. It regulates the blood pressure by sending the messages to the brain and the kidney to help raise the blood pressure. Neural effects. Angiotensin 2 stimulates an area in the brain called the thirst center to help increase the blood pressure. This thirst center is located in the part of the brain called the hypothalamus. When the thirst center is told by the angiotensin 2 that the blood pressure is too low, it creates a sensation of a thirst. Drinking the water then increases the fluid volume in the body. Angiotensin 2 also stimulates the body's fight or the flight response to increase the blood pressure. This response, which is usually activated during the stressful situation, causes the heart to pump more quickly and forcefully to increase the circulating volume and the blood pressure. Renal effects. Thirst is not only the message from the brain in response to the low blood pressure. Angiotensin 2 also tells the hypothalamus to increase the production of the protein called the antidiuretic hormone. This hormone travels from the brain to the kidney and tells the kidney to reabsorb the water from the urine. Angiotensin 2 also acts directly on the kidney to further help increase the blood pressure and the blood flow by telling the kidneys to to constrict the small blood vessel to help increase the blood pressure. They acts to increase the sodium and the water retention. They regulate the rate of kidney filters fluid. As a long-term regulator of the blood pressure, the classical RAS pathway has a constant baseline level of the activity and actually works much like the gas pedal of the car. Constant pressure on the gas pedal is required to keep the car moving forward, even when you just want to go at the same speed. If you need to, though you can press the pedal down suddenly in order to quickly speed up. Likewise, the constant activity in the classical RAS pathway keeps the blood pressure steady over the long term, but sudden bursts of action are possible when the quick response is required. Classical RAS pathway is known to be the important factor in the heart disease. One heart disease that is common in the United States is a chronic high blood pressure, also known as hypertension. According to the Centers for the Disease Control and the Prevention, hypertension affects approximately half of adults in the United States. Some people with the hypertension have the no identifiable cause of. This is referred to as the primary or the essential hypertension. Other people have the hypertension due to the secondary causes. Secondary hypertension can be caused by the hormonal imbalance in the classical RAS pathway. For example, a tumor in the adrenal gland can increase the excessive amount of the aldosterone and lead to the fluid retention and the high blood pressure. Many scientific papers, conference presentations, and the textbook have been written about the importance of the classical RAS pathway in the blood pressure regulation. This is an area of research still being pursued by the scientists more than 50 years after the discovery of the system. The details of the renin, angiotensin, aldosterone system continue to be investigated and could help us further understand why people develop the primary hypertension, why some people don't respond well to typical high blood pressure treatment, why some people with the high blood pressure develop more complications than the others. For example, the black patients with the high blood pressure often don't respond as well as the ACE inhibitors as to other medicines. This is likely because African Americans have the different level of activity in the renin, angiotensin, aldosterone system, which makes them less sensitive to drugs that work by blocking the system. Renin angiotensin mechanism inhibitor and the high blood pressure. Several effective high blood pressure treatments have been developed as the direct result of our understanding of the renin angiotensin aldosterone system. The ACE inhibitors stop the conversion of the angiotensin 1 to the angiotensin 2. Angiotensin receptor blockers prevent the angiotensin 2 from binding to the blood vessel and causing the vasoconstriction. Water pills are the diuretics. They help to get rid of the fluid by telling the body excrete the water and the sodium through the urination. How the alternative pathway works. Eventually, angiotensin 1, 2 and aldosterone are broken down into the other molecules. Some of these other molecules can act in the closely related alternative pathway that counteracts the effects of the classical pathway. Important members of the alternative pathway include the angiotensin converting enzyme 2, angiotensin 1 to 7, angiotensin 1 to 9. While the classical RAS pathway controls blood pressure and the body fluid, it also has a complementary negative effect on the body that prevents the inflammation. Some of the inflammatory response of the classical RAS pathway include blood vessel narrowing and the constriction, increase in the lung inflammatory response, increase in the cell stress response, increase in the arrhythmias or the abnormal heartbeats, increase in the insulin resistance. Angiotensin converting enzyme 2. Although ACE protects the harmful inflammatory effects of the angiotensin 2 and the presence of the COVID-19 virus, ACE2 is unable to serve in the protective manner. It is preoccupied with the facilitating viral entry into cells. This leads to the reduction in the anti-inflammatory response and a worsening of the COVID-19 symptoms and the infections. What is the function of the aldosterone? Aldosterone is a hormone that helps the body manage the water and the sodium level. It does this by increasing the amount of water and the sodium reabsorbed by the kidneys, which has the effect of increasing the blood volume and the blood pressure. In some cases, an imbalance of the aldosterone can cause the high blood pressure. Thank you.